And I suppose it's time for us to move forward to our second speech, to our second talk. And today we have, by the way, two speakers in one talk. It's a bit unusual for us. First of all, let me introduce my colleagues. Sooner, he is a data science team lead and optimization offering lead, which sounds, to be honest, a bit cryptic to me. And other than that, we have Kostya from Gurobi, who lead the global technical account management team at Gurobi Optimisation. That's a long title. And, well, just a short warm-up. Ruslan, you mentioned you write in Python, and I know that Python is really good for data science. And because our second talk is about data-driven decisions and optimization, how often do you do any optimizations?
Yeah, to be honest, I have to do really often optimization, but my very important optimization I'm trying to do every month when I get AWS bill for our solution architecture. And right now I'm working in the project. It's totally serverless project, and we have hundreds of lambdas, tens of SQS queues, tens of DynamoDB, terabytes data in the S3, and we usually facing with trade-offs. What should we where should we spend more, or our reliability, or to store more data, to be more cheaper in development, or to pay more to AWS. So it's a really trade-off. And usually we're selecting something, but sometimes we can find optimizations to reduce cost without reducing anything else. And it's to find these optimizations, it's really important to us. And I believe that today Turner and Kostya will explain how to make optimization from mathematical perspective.
Yes, definitely. So it sounds like you have to make a decision, and in order to make reliable decisions, you need to analyze a lot of data, and especially a lot of analysis up front. Yeah, that's suppose a good good introduction to the talk. And guys, the floor is yours.
Thank you. Let's start. It's good example that you give there. Like, for example, you were making decisions, right? You have a lot of these costs and trade-offs that you have to deal with it. But if you have to go to every possible scenario and every possible conjunctions that you can do it, it's almost impossible, right? So why not have a software that will help you with this decision process, right? So that's the talk that we are going to talk today, right? Talk.
Yeah.
So we are going to talk about like data-driven decisions and optimization as a tool, right? I'm here from the IPAN, Costa is from Gurobi to talk about this. And the idea here is how optimization can help as data science, software engineers, and everyone to make the essential decisions and make the optimization better, right? So if you have like a software solution that will help you to decide how you're going to distribute your Lambda functions and how you're going to distribute your resource in the Amazon, for example, it's going to help you to save costs, right? So that's the end objective. So first, I don't know if I should like show to use, but you guys sure know that decisions are quite important, right? But I want to show some numbers here and have they understand that how important decisions can be, how we can get closer to decisions. We have a major issue with multiple companies that we are far away from decisions. And what are the major issues? What are gaps we have on this part that it's not enable us to do like better decisions, right? Have better decision process. So just some key factors here. We have a report from Forrest on how to make better decisions. And there is several ways that can help you in the process. If you use optimization, you can improve efficiency, you can increase revenues, we can reduce cost and improve competitiveness in the end. In the end, if you think about distribution companies like DHL, Amazon, and other FedEx, they are all competing for the same resource, for the same users, right? So if you have higher cost than you're competitive, you are in the disadvantage here. So optimization can help during this process, right? So just to you understand what kind of projects we are talking about and what kind of decisions you can have here. So I just keep 6 simple examples here in order to just grasp your imagination. Later, Costa will like dive deep on this. But if you have budget distribution, just give here an example in the beginning. If you want to distribute your budget for multiple things and you have to maximize your return investment, you have multiple constraints, you have multiple objectives, you can use this as optimization problem. If you have a wind farm and you want to like distribute the cables and have the flow that you have, energy flow that you have there on the cables, and have proper cables installed in order to be able to handle the demand that you have there, this is an optimization project. If you do job matching, we have here at Etipan, right? So if you want to assign people to specific roles, right? You have to see the CV of the person, check what's the requirements of the roles. You can do a multi-step process that you have like a machine learning model that will like help you to match the NLP part, but also optimization project that will assign specific people to specific roles, right? Packaging, marketing campaign, it's one that people will not think about, but it is, it can be modeled as optimization project. And network design also, like, for example, if you want to define where the place you should like put your data warehouse or your storing house around some place, you can construct this as a mathematical optimization model. So you now understand a little bit of what kind of solutions and what kind of software we construct during this process. But why we are failing sometimes in order to deliver the value from this, right? So companies nowadays, we are storing a lot of data. We have a lot of data on those companies, but we fail in order to go all the way through the path, right? So normally companies will be on different levels here, but they have normally a lot of data. Sometimes they have some structured information or they struggle with structured information and they want to extract knowledge from this, right? So you have all those steps in order to be able to go to the decisions. And people now look at those 3 initial steps a lot, like data, structure information, extract knowledge, but they don't look at the end of this path, right? It's decisions, right? So we normally will have like a BI application, we have data science application, extracting knowledge and going all the way there. But you still have this person that has to read like a lot of dashboards to see a lot of information and make the decisions. And we don't help this person with the decisions, right? We don't suggest things. We don't say, oh, we should do this. And we don't interact with this person on the decision level, right? We interact on the knowledge, right? And also it's the differentiation that we have on the data science community, right? So knowledge, we are talking about descriptive when we are describing thing with like exploratory data analysis, diagnostic when we say that something happened because of this, predictive when we talk about like the future, right? So all this is still extracting knowledge for something that happened, right? Prescriptive is when you say to me that I should do the decisions. I should build this warehouse here. I should layer my cables for the wind farm this way. I should distribute my budget for like cross multimedia this way. That's the amount that I should put on each one of those channels. It's not just knowledge, it's decisions. And that also comes with more value. As closer as you can get to decisions, you get more value, right? Because you are making a real data-driven decision. So, but company fails on this path for several reasons, right? So one of those that I'm seeing a lot here and at Etipan also, that we over-focus too much in machine learning models. Just example, we talk about a lot of ChatGPT. People are using ChatGPT for those kind of applications that you just saw, and ChatGPT will do like a very, very, very bad job on that, right? Or using other machine learning models to do something that's classical optimization problem, right? Optimization has a long time and was able to solve different challenges and a lot of them. So we know what kind of problems you can use optimization and know what kind of problems you can use machine learning, and you can use them together. It's fine, but don't use like a machine learning model to optimization problem. There is others that lack of leadership, lack of depth and understanding, and lack of like monitoring the solutions and make sure everything will go to production. And this leads us to like suboptimal and wrong decisions. Again, remember that decisions based on misleading or incomplete information can be very bad for the company. And also come another say here that's quite common on this on data science, that a lot of business, they have a lot of they say that it's very important to have data science analytics, but they fail in order to deliver those solutions, right? And that's all part of this. And in the end, it's high cost, low revenue, low profits. That's the result of this bad decision process. Okay, so now understand what's the problem that we have here, and what's like the overview of optimization. And now I want to dive more deep and see how we can change this, how EPAM can enable companies to change this scenario that you're seeing, and what's the strategy here that we have at EPAM. So the first thing is our differentiators, right? So everyone knows about like the engineering excellence of EPAM. We are well known in the industry for this. We have our industry expertise, our verticals that we can talk about: digital twins, supply chain, manufacturing, and others. We have our consulting part for helping with this. And the third leg here, it's like the strategic partnership, right? We want to bring a strategic partner for the areas that we cannot cover, right? EPAM cannot cover everything. We can cover a lot, but still there is gaps that we need help for third-party companies, right? So one of these companies is Gurobi, and that's why I want to bring them in order to talk more about this and dive in some topics here. And it's a company that has a long history with optimization, so it can help a lot company in order to our company in order to go further, in order to enhance our portfolio of products around optimization, and also tackle more difficult problems in optimization. So I will leave set the floor to Costa. Costa, are you here? Yes, you are.
Yes, I am. Absolutely. Thanks, Tuna. So so far a lot of theory. So let's do just a little more theory until we get to play with something. Yeah. So the name of the company is Gurobi Optimisation. Usually when people talk about optimization, they mean do something better. You know, we all optimize, right? We're changing something. We optimize our life. We optimize our productivity. We optimize a lot of things in our lives. Mathematical optimization is the idea that you can model the decision situation. So you take the whole decision situation, formulate it, right? It has to be complete. It has to consider everything that is included. And then you take a piece of software, which is our product, put it in there and ask a question, which is, this is the situation. These are my goals. Please give me in that particular decision situation, in that system, a solution or a lot of solutions that drive me as best as possible towards my individual objectives. That's the key part. So essentially the mathematical part gives you a proven optimal solution. So it's not just doing something better, trying as hard as you can, but it's finding those solutions and proving that it's impossible in the given system to get any better. And that's the core of the technology. In terms of software, we are quite boring. We are a library, right? And you need to use a programming language or a modeling language to use our product. So we don't have shiny user interfaces. That is something that Tuner and team create for particular use cases. So let's look at this thing in action, Tuner. Would you be so kind and advance to the next slide? All right. So very briefly, why Gurobi? Well, it's quite simple. We have 3 founders. These are the first letters of their words, and they didn't come up with any other name. So it could have been Bigoro or Rugibo, but they decided it's Gurobi. So that's the reason why the name is called. All 3 founders are still with us. And when I joined, it was only the 3 founders, 10 more people, and and myself and the company. We've grown a bit. We're now at 130, I think, is the current number. Next slide, please. All right. So, and the question that you usually ask is not, hey, software, give me, you know, compute something. The answer that you're looking for is an outcome. Yeah, so you're looking for a result of your decision, not necessarily the exact details of the decision. And the idea is that you state the decision situation, you consider everything that is important to you, and then let the computer, let the algorithms, let the math do the rest for you. In terms of machine learning to optimization, machine learning gives you a prediction. So what will happen? But it doesn't tell you what you should do about it. Right? It's simple as that. So take the weather forecast. If you know tomorrow the temperature, whatnot, the question, what should I be doing? What should I be wearing? What should I do in the afternoon? Is it going to rain? Will that prevent me from doing any activities? That's a whole different question. And so usually when you have the question what to do, there is a lot more to consider than just, okay, this is my forecast. And here are just a few examples that you see in common industry applications. Right, so you have global trends. You have a big focus on non-economic functions, which is green targets. Right, energy has become a relevant cost factor. Stuff gets connected all the time. So what I'm trying to say here is the decision situation become more complex. So they usually exceed the capacities of our brains, and that's why it makes sense to not try to solve them on paper, but put this into a computer and ask it to get solved. The same is true for the goals, right? So of course it's economic. We want to make more money, reduce costs, and increase profit. But there's much more. There's a risk side. There's the stability, robustness, agility side. It comes down to different KPIs for the same system. And when you optimize, the question is, okay, what are the relevant KPIs for you? So what is the direction to go with that optimization? And the beautiful answer with our technology is pick what you need. We don't care. For us, everything is a quantifiable, it's a function, and you pick your function or your functions, right? There can be multiple objectives to do that. Next slide, please. All right, so Gurobi, oh yeah, here's the marketing slide. You know, we've grown a bit since 2008. We have now, I think the current number is a little bit more than 2,500 active customers, lots of PhDs in optimization in the company. Yeah, our focus is this one product. The Gurobi Optimizer is the one product we have. We only have this one. It's all we do. And we have a very straightforward focus. That is the performance of the product that improves all the time. That's the improvement of, you know, on the feature side, on the convenience side. So we make it more accessible, more usable, more convenient, achieve more with less code, essentially. And oh yeah, thanks. That's the next slide. Of course, we all like to show our logos. 70% of the Fortune 10. You can do the math. That's 7 out of 10. Yeah, that's the marketing slide. We really, so there's hardly any major company out there that doesn't use that, and it's also very likely that you never heard of us. It's probably one of those technology that you essentially you get exposed to it every day, but you don't notice, right? Because something was planned or something was done with some software system, and you were affected by it, but you never noticed. The fact that the energy that you consume right now, yeah, whatever the electricity grid, the stability was planned and optimized with our software, you would never notice. Yeah, so we are one of these. So the biggest technology you've probably never heard of. Okay, can we move on? So let's play a little bit with it. And one of the things that we've created to give people a better understanding of this technology is a game. And it's called the Burrito Optimization game. And I like gamification because it kind of you get the idea and you understand the challenge before you get to the gory details. So the idea of the Burrito Optimization game is you operate a fleet of burrito trucks. Yeah. So your job is to decide, okay, how many trucks to put where in the city to sell as many burritos as you can. Very simple. And so the game that we've created as an online game is you get the city, you get the cost function, you get the demand. So that's your forecast. So that's like what you expect to happen. And then your job is to decide how many trucks and where, right? And I'll briefly show you how this game works. On my so I'll share my screen, Tuna. So hopefully you can share yours back when I'm done. So just Google the Gurobi burrito optimization game. You can easily find it on Google. It's a burrito optimization game, and in order to play it, it opens a web application, and what you can do there is you can play against our product. So here's the situation. Here's the city, and you know a few things. You can position trucks, right? So this is the city. You can put trucks on streets. We have predefined points for this, and you know a few things. You know the cost for each trucks. That's probably mostly cost of the truck and the person operating it. You know the ingredient costs for your burritos, and you know what you can sell, so that the price. It's a $10 burrito. It's not really dollar. This is, I think, a special Gurobi currency. So whatever that is. And so the task here is now you have this city map, right, that you can see right here, and you have burrito trucks. And what you can see here in these red circle things is how much demand. So people are there in the building. And what you want to do is you want to put as many tracks as needed, but not too much, because trucks compete for the same demand. So the way to play that game is you kind of take a truck and you put it somewhere. So we could go like, oh, here's 50 people, 20 people, 25. Maybe it's a good idea to put a truck here, right? And if you do this, you will see the demand that you can pull from this truck, right? So from the 50 people in this building, 31 will come and have a burrito from your thing. Depends a little bit on the distance between you and the train. You can say, oh, this is already nice. Let's see if we can get some more. And at the bottom, you can see, okay, what is the profit today? So you see the cost for the trucks, the cost for the ingredients, and also the revenue that you make out of these customers. So you can do more, and you can say, okay, well, let me scroll down. Maybe there's another place where I can get some more. Maybe here. Here looks nice. Maybe some demand here. Let's see. Today's profit is 600 with that truck, and if I remove that truck, today's profit is 530. So that just gives me $70 or whatever on top of it. Doesn't look too good. Maybe I try something else. Maybe I go rather over here and put a truck there. Maybe here. Yeah. Oh, and then my profit goes up to 760. That was probably a good choice. So another question is, okay, in this system, what is the optimal number of trucks and where to put them? Right? And we could say, okay, maybe we should do more. Maybe we can take another one and put it somewhere. So remember, we had at 760, and let's say we now put another one here. Wow, this is 730. It gets worse. The additional truck doesn't pay off. So let's just remove it and say we're done. And what now happens is you let Gurobi run and answer the question, okay, what is the optimal solution here? And what you see there is, that wasn't good. We added 2 trucks. We tried to get, a part of the demand, but technically it's 43% worse than the optimum. So if you give that problem to our product and you ask to solve it, you get a total profit of 1,345. Yeah, and it only takes us a fraction of a second to find a problem. So that gives you an idea of the complexity of the decision situation and the advantage that you get from a computer program to solve it. Tuna, can you go back to your presentation so we can continue with the slides? Thank you. All right. Good. Let's do a quick view on some more aspects. So what do you need to who does this? So who writes these models? What do you need to do here? Technically, it's a craft, right? It's a little bit of skill and a little bit of experience. So stating a decision problem in a mathematical way, that's something that you have to learn. It's called modeling. And you can learn it from a textbook and then through some experience. It's essentially taking the reality, creating an abstraction, and putting it into problems. So a little bit of linear algebra and calculus is helpful, and then you need a language to use it. Most of the time, a programming language. So Python knowledge is also important, Python, and we do it.
Python.
Yes,
It's not Java.
Python. Absolutely. It's the number one modeling language that our customers use. Absolutely. And you can use it, right? In Python, you would say, just use Gurobi. Here's your problem, variables, constraints, and so on. And that's how you do it. Next slide. I think we have this in a little bit more detail here. Exactly. So and there's Python on the left here, right? So what you do there is you state this decision problem in essentially 3 steps using Python. So the first one is you define what your decisions are. In the burrito game, that's the assignment of trucks to locations, right? It's put a truck here, put a truck there. That's your variables. That's something you can decide. And then you have objectives. And objectives in the burrito game, well, total revenue or total profit, right? So you have to essentially take your costs, and then you take your revenue, and you calculate the total result over the whole city with your burrito trucks. But then you also have constraints, and the constraints define the details of your problem. In case of the burrito game, right, it's okay. So there's the demand that you can get. So you have to kind of compute how much demand can a certain truck pull. So there's a limit to it. And a few more things. So that has to be complete in order to define the situation, and then you can put it into a program and then ask the solver. So it's usually this 3-step approach. Understand your problem, understand the situation, define those points, put them into software, and press play. Good. Next slide, please. Most of the time, our software is deeply integrated, so you don't really see them from the front end. I look at this as the onion slide. So usually the solver library is very in the middle, and then there's like an interface, usually the modeling part around it. Sometimes there's another modeling interface, so something that translates problem statements into what the solver can understand. But then usually we have the functional layer around it. So what's the service? What's the software component, the module that does something? Yeah, that computes the optimal plan, the shortest route, whatever it is. And that is below, the application itself that comes with a user interface. So Gurobi is, deep down below in the inner core of that onion. Next slide, please. All right. So honestly, when you talk to people and you say, hey, you should be using mathematical optimization, people go like, huh, mathematical? Ooh, that sounds difficult already. And optimization, hey, everybody does optimization. So we like to, a little bit also on the marketing side, we like to talk about decision intelligence. So it's part of a decision-making process, and it's intelligence also compared to artificial intelligence, because it puts an intelligent, systematic approach on a decision-making process, right? By making it this quantifiable, modeled thing that allows you to work on a problem statement and solve it right away with your computer as a decision support system. So think of the computer giving you options and better options, or the best options in most cases, for your particular decision situation. Next slide, please. So let me look at the time. I think we can do this. So we've seen the game. Now let's look at something that is not just a game, but a real-time real life application of this. So, and if you like to play with it, you can do it. This is not just Kostya showing some prepared demos. There's a website, and it's called, guess what? demos.gurobi.com. demos.gurobi.com. And you just need a website account for this. You can just sign up. It's all for free, and it has a bunch of applications. So those are demo optimization applications with like the most frequent use cases that we see for this technology. So from staff scheduling to coverage, facility location, which is essentially the burrito game, and the most famous, which is traveling salesman. I'll just quickly walk you through something that also Tuna already mentioned, and that is resource matching. And resource matching is the idea that you have a machine learning algorithm that does scoring for candidates for jobs. So you take the candidate, you take a resume, and you take a job, and kind of from the resume, you're trying to compute a score depending on the skills required. And then when you have these scores, you have jobs. And now the question is, how can you create the perfect match between the scored candidates and the jobs that you have? Which is then the question, what to do, right? Given the scores from your data. And there's a tutorial here. I will not go through all the details looking at the time. There's a tutorial here in the system that walks you through it. But essentially, what you do is you work with a scenario and you call it whatever you want. Example, and you say, okay, we start with a predefined set of data profiles. So we have candidates here with a resume. Here's an example, right? This is just text. And what you do then with the machine learning phase in the beginning is you try from this text to compute a score. So we're not going to detail here, but this is supposed to give you a score, a matching score from the resume to certain job requirements. And then you have jobs, right? So you have a job ID. We're looking for a data scientist that uses C++ and SQL in finance. And we need at least a score of 10% for something here to match. So those are the jobs, those are the candidates. We can, if we like, here pre-assign, so we can kind of do something before the optimization starts. But in the interest of time, I'll just push the optimize button here, because what this does now is two things. It computes the scores from the resumes, and it computes the optimal allocation from resources, people, to jobs, so that based on the KPIs that you're looking at, you get the best possible assignment between resources and the jobs. So what it does is it essentially calculates for the names for jobs, the roles and the technologies and the domain a score based on the resume, and it gives you a solution, which is the assignment. So Keith is doing, the developer for web development for marketing. Tara is doing the same for finance, and Liza Smith is for something else. And we can see the total matching score here, and you need to hire additional people for the other jobs. So you will not use the existing candidates for this. And then there's also a KPI. A cockpit here where you can kind of see the quality of your solution. Like, is everything fulfilled? Do I have enough people? What is the average assignment quality? So the average matching score over all the assignments, etc., etc. In the interest of time, this is just a quick walkthrough, but this is one of many examples where you take both sides, right? The machine learning part, so you extract some useful information, in this case, automated scoring, and then the optimization part, the model answers the question, what to do now? What is now the optimal way of deciding something that gives you the best possible outcome in terms of the KPIs you're interested in? Okay, wow, we're really quick. We're really quick today, so hopefully that's not an overload. But happy to take questions later on. Tuna, would you mind switching back so that I can wrap it up and you can continue?
Amazing task to ChatGPT. You can get your job description and to ask ChatGPT to generate resume.
Yes. Those things can be combined.
You saw mine?
Yes, of course I have seen a meme.
I did it.
Oh. No. You generated a meme using ChatGPT, and next I got a summary of that meme using ChatGPT back.
Yes.
Hey, ChatGPT can even help you to write optimization models, at least, the basic models, because, hey, this has learned from, stating a model is just a different language, right? It's a formal language to express a decision situation. So ChatGPT can indeed help you with that. It's not very smart, honestly, but as a productivity tool to get you started with something you can then take and improve, definitely. Yeah, it's really nice.
What's your impression regarding GitHub Copilot? Because I've tried it from efficiency point of view, from amount of code it generates, it's a fantastic tool because it generates a lot of code.
Yeah.
Yes, exactly. But next you need to spend 3 times or 5 times more times trying to understand what this code does and how to align it with, let's say, with our existing libraries, governance, tooling, frameworks, and so on. So Well,
and requirements.
And requirements, obviously, because as for me, for example, Copilot is a good tool for code generation, but not for solving problems, at least at the moment.
If you get paid for lines of code, it's amazing tool.
Yes.
Raise your salary.
Hey, I hope so there used to be a time when, slog, so a metric, so lines of code used to be a kind of a measure for something. Hopefully we are past that. It's certainly not, right? So the less is more. And in terms of decision modeling, it's actually something that we're doing ourselves. So we're trying to improve our interface all the time so that less codes gives you more in terms of better maintainable, less error-prone code. So I would always argue that less is more, because the danger is if you have these huge blocks of code with all these interesting things in there, they become software components nobody wants to touch anymore. So the decision situations change. There's new aspects, but nobody wants to touch this piece because you could break something. So keep it simple, keep the model simple, keep the code simple, and don't try to generate something that is just big. Yeah. My take is less is more. Express more with less code in this, at least in this domain, certainly.
Good,
all right,
Tuna.
Yeah, we have a few more. So this is, okay. I think, my last one. Just to wrap it up. So how do you find use cases for this technology? Right. Of course, you can go to our demo site and get inspired. But usually, it's a very simple pattern. And the first one is complexity. Right. There are easy decisions. Right. Where to go to dinner tonight. Yeah. Easy decision, not too complex, not too interconnected. I mean, depending on the people, it might be, but usually it's not. So it's a problem structure that is simple, that is easy to write down, and it's not too difficult to do it. But as soon as you have the complexity, like when the problem structure exceeds what you can do with your brain, it's something to look at, because the computer can consider everything when you can't. Right, so that is, and of course it's always about efficient resource allocation. I think Ruslan in the beginning said something like don't do less, but with less costs. In other words, it's definitely better use of existing resources. I mean, that's the same thing, right? We have 3 burrito trucks. The difference is where we put them. So the cost structure doesn't have to change at all. It's the outcome that changed based on a smarter decision. So that's the whole complexity of all those choices you have. It's totally normal for an optimization problem to have more solutions than atoms in the universe. That's just normal. That's the business. And the beauty of the algorithms is that they can do smart things and reduce this down to something that is manageable and can be computed by a computer. Second pattern, quantifiable. Feelings cannot be quantified. So this is for stuff where you can put a unit on and a number on. Yeah, and cost is good and efficiency is good and these type of things. Usefulness is already dangerous, and there are a few things that are really quality things that are hard to measure. This is difficult. So quantifiable is really, really important, because that allows you to state something that can clearly be computed, so that there is no interpretation of what the quality actually is. Efficiency. Sorry, one. I think the slide as well. So, if you are already optimal, right? If you know that you can't do any better, this is already good. Well, then the potential is small. Most of our customers improve costs or something by 1% or 2%, but for millions and every day. So it sums up to a huge amount of saving or improvement of efficiency. So it's important to identify that potential in the beginning and say, okay, what would it mean if we would be able to save 1% or so here? Right, so that's the third part. And honestly, number 4 is, if you write algorithms that are particularly for a special problem structure, and the problem structure changes, it usually means you have to adapt your algorithms as well. The beauty of this technology is you just change your model. You change a constraint, you change your objective, doesn't matter, you don't have to take care of it. So you just change the statement of the problem and leave the solution to to the engine. And the right-hand side of this slide is what I call our museum of case studies. Our website is full of this. I think every industry is in there. So another way of looking at it is find your industry and find use cases and see if that is something where you say, "Ooh, interesting. I never thought of using a technology like this." But this is the general way of finding use cases for this technology. All right. In the interest of time, I think we should skip the next one, Tuna, because it's essentially more industries, I think. Yeah, exactly. And over, yeah, okay. So I'll take a breath and shut up for a moment and give it back to Tuna for a few more things.
So thank you, Costa. So now with this overview that Gurobi gave us, you understand more about like the optimization process and the decision process and what Gurobi can help us in order to achieve, right? What else EPAM can bring here to the table, right? So there is several different visions that the client needing to do in order to be able to get all the way to the decisions. And that's the part that we excel at EPAM, right? So if the client's having problem with data issues, we have the data factory offering for this. If it's client, it is struggling with cloud or implementation of software, we can help, we are covered. If they need artificial intelligent models, we have our data science in order to help with this. And the gap that normally we have with this, that's where come Gurobi, right? So for example, if we have like a very difficult optimization problem that we cannot solve, we have Gurobi in order to cover us. So optimization problems can be quite complex, and we will not be able to solve something like this with the open source libraries, right? So Gurobi is here to help us with this. And you saw on the Costa slides, the onion slide is quite good to understand that there is a lot of things around Gurobi, right? Gurobi is like the core and the brain of the solution, but you have all those things that has to be constructed, and that's what EPAM helps a lot. So this is the stack side, right? So we have our engineering excellent here. That's unlocked by that, but also have to come from the business, right? So you have the domain focus, business strategic, in order to construct solution and use the decision optimization products in the middle, right? So we stack everything this together like sandwich, and that's our offering from optimization point of view. During the offering, we have this methodology that's it's similar to others, but there is some tweaks that we have to do specific to optimization, right? But we have those two like main path, right? Actually three. The learn and plan, build and test, and productization, right? Learning plan, it's very common on data science and projects in general, especially if you have dealing with innovation, that you want to understand the business first. Right? You go with the business and clearly understand the goals and what you want to do it, right? So Costa talk about this, right? What your constraints, what your objective, what you want to do with the solution. All this we want to like map and understand, right? Then as data science, we have like data collection, analytics, we construct the mathematical model after this with the data that we have, and we measure, right? We have to have clear measures and have to have the model that you construct have to have the KPIs clear expressed, right? So if you are modeling a mathematical model with different metrics than the initial one that the business wants, it's going to be a disaster, right? So you are looking on the wrong direction. And in the end, you have to do the productization of this product, right? So that's a lot of software engineering here. Pipelines, automation, CI/CD, people, it's quite important. I also think that people neglect a lot. There is someone that's going to use this solution. You need this person on your side, right? On how to make the process that this person is going to use this solution, how to facilitate the use of the solution. Then we have monitoring. That's make sure that solution is still going to work. And if there is something wrong, if it's going to alert, you can talk about the machine learning models, for example, retrain the machine learning models. Also with the mathematical optimization models that they can run again and give different solutions. And maybe like if you add a new constraint, the model is still going to run, still going to work, right? So there is all this. And in the end, you have the review process that you come back, right? But that's the part that you normally know about. So just two examples here. We have several dams already on EPAN right now. There is much more that I can put on slides, but here we have two examples that are quite important ones, right? We have the optimizing helicopter routing, vehicle routing, and optimizing routing is quite common. I'm talking with FedEx, for example, right now in account about about this. And you can have ships, trucks, helicopters. It's quite common, and optimization is a very good tool, and it's using by many companies on that process. One that's not that common, and also like Custom showed us here, that's another example that people sometimes don't think as a optimization, right? So this is the cross-media budget spending, right? So if you want to distribute your budget for multiple companies, imagine that you come with a big CGP company that they want to invest and choose between like TV channels, digital channels, YouTube, Facebook, and so on. So how they can distribute this and have the constraints in place, right? So there is a limit that you can, how much you can invest in each one of those channels, and still have the better reach as possible, right? And another one that I remember here that also good, like case that Kostya showed quickly there, it's the NFL case, right? That Gurobi talks a lot, not from IPAN, but Gurobi talks about this, about how you can do the scheduling of the games, right? Imagine how complex it is to do the scheduling of the games, and it's doing using Gurobi, right? So it's another example of an optimization solution. What we have here at IPAN also, in order to help with the pre-sales activities, are demos. We have like a accelerator structure that we can construct quick demos with a very lightweight stack for pre-sales, right? So we did like 3 times already. One for SG optimizer. When you talk about supply chain, there is a lot of things that optimization can help. Especially in this case, there is like 3 main things competing here. So we have CO2, you have waste, and you have tax, right? So the company wants to look on 3 different directions, and optimization can do this, right? We can write the object function in other way to handle those 3 different directions. Telecom company, we did like a pre-sales activity with 5G rollout company, where they should build the towers that they have that they're gonna build, right? So where they should build the towers, where and what will be the costs, what will be the reward for building towers here and there. That's very similar to what you saw on the burrito game. The difference, like the range of the towers, right? Facility location, where should I build my warehouse, right? All major distribution company will have the problem like this. Supermarkets will have a problem like this. Stores that sell products in general will have something like this. Where should I build my warehouse, and where is my client? How can I cover my clients or my stores that I will have to distribute for those stores in the best possible way? And all those 3 are accessible right now. I will leave the links in the chat soon, and you can access through like the IPAN VPN, right? So all those are 3 demos that you can access. And just to wrap up, and probably we are just on time. What's the wrap up of the presentation, right? How important decisions are, right? I think this is something that everyone will say, oh, I know that decisions are important, but people fail to grasp how much, right? So how much I can save on costs on this distribution, how much I can save on costs on routing, how much I can save on costs for airline companies, how much I can increase my profit in that direction with good decisions. What's data-driven and what's optimization can help with this process. IPAN, it's very well positioned on this process. We can cover different directions, and optimization is just like the cherry on the cake here, right? But we have all the other directions that we can cover the company. So this can start as an initial POC project, but then like evolve with bigger and more engineering, more artificial intelligence, more cloud offerings, and that data factory, and so on and so forth. And our partnership, it's our to fill our gaps, right? So if we have gap like we have here with optimization, we have Grop to cover us. So that's covering all the possible directions. And so IPA, it's like ready for this market, and we are able to tackle different challenges here and do different things. We are already done for several years, but now the idea is to like productionalize this stream of products and create like a good and big stream and accounts around this. And thank you.
Thank you, colleagues. Thank you very much. Thank you for the fantastic presentation and for the great examples.
Yeah, burrito game, amazing.
Yeah, game is definitely amazing, but you know, you are expert in data-driven decisions, so that I have a question to you. So colleagues, what would you recommend Ruslan to do in order to optimize his AWS costs? Again, getting back to the use case he provided at the beginning. So what should we sacrifice? Cost, reliability, or storage?
Nothing.
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 Just to continue pay these bills. Yeah.
No, so I can tell you. So I mean, AWS is a nice example because what you have is resources that come with fixed and variable costs, and you have a demand for these resources. So what you in fact want to do is you want to utilize those resources to the maximum extent, which means no idle time and you know the maximum acceptable load on all those systems all the time, and that is an optimization problem. It's essentially allocation of resources depending on depends a little bit on the time frame. We have a lot of customers who do this, essentially cloud operations, service operations, all these things. It's an optimization, and they don't sacrifice anything. I mean, technically, I know a resource gets loaded, and maybe the service level will degrade at some point, and sometimes that's the trade-off that you're willing to accept. But before you get there, it's making sure stuff doesn't run idle first, and that is already an optimization without any sacrificing anything. It's more it's taking the resources and using them in the most efficient way. That's my take. Sorry, Tuna, maybe you have something for that as well.
I don't know if I should like go dive deep on this, but it's actually like a quite difficult optimization problem, right? So because there is fluctuations on the costs and a lot of variables right there, right? So it's a thing that I think people still do like heuristics way. So they pick it up like and guess things and try to do this. I know that a company quite close to mine try to do optimization on this, but you can save a lot of money if you do that, right? So they do some like some run-ups with this in order to save costs, in order to run like a big instance that they want to use like a AWS resource, and the results were like quite impressive. But depending on the structure that you have, it can be, if you're using like 20, 30 different resources from like AWS, can be a nightmare, right? Because you have different costs for all of those. It's even sometimes difficult to like rate to see what's the cost fluctuation and understand that. But if you're using like a small number of solutions, you can do an optimization process there in order to help you with the decision.
So I suppose it was a productive 2 hours of your time, colleagues. Thank you very much, everybody who joined our session today. Thank you very much, our dear speakers. We are really happy to have you today, and we really believe that you will definitely join us at least one more time, and we really like our audience. So, colleagues, as ordinary, there are many different things that are happening around, but nevertheless, you can join UK Engineering community to get updates. We're on we're a community platform, also we're on Teams, and I suppose we should do anything else like a YouTube channel, aren't we?
Maybe. We will think about it.
Yes, definitely. So keep in touch, stay tuned. Thank you very much.